This video covers Spelman and Morehouse's homework for the last week of RP1 benchmark week. First is Monday. On Monday night's homework, we're practicing dividing fractions by fractions and fractions by mixed numbers. The first question says, a shopper buys cat food in bags of 3 pounds. Her cat eats 3/4 of a pound per week. How many weeks does one bag last? We know that this shopper is starting with 3 pounds of cat food, and her cat is eating 3/4 of a pound each week. That means we're asking the question, how many weeks can we use 3 pounds of cat food? In other words, how many 3/4 fit into 3? You can think of this question as taking a 3-pound bag of cat food, 3 pounds, and splitting it up into sections that are each 3/4 large. Of course, you could solve this by sectioning off each 3/4 as 1 week, or you could simply divide 3 bags into 3/4 size groups. I know that 3 wholes divided by 3/4 is the same thing as 3/1 divided by 3/4. Whenever I'm dividing a whole number 3, that's identical to saying 3/1. 3/1 divided by 3/4, we keep change flip for 3/1 times 4/3. When I multiply fractions, I simply multiply across. 3 times 4 is 12 over 3. I always want to see if I can simplify my fraction by dividing the numerator and denominator by the same thing. In this case, 12 divided by 3 and 3 divided by 3 gives me an equivalent fraction of 4/1, which is the same thing as just saying 4, and in this case, it's 4 weeks. I know that a 3-pound bag of cat food lasts 4 weeks if I'm using 3/4 of a pound per week. The other question that we'll model is question 6. Question 6 says, it takes 1 week for a crew of workers to pave 3/5 kilometer of road. At that rate, how long will it take to pave 4 kilometers? This is similar to the last question in that we're taking the whole number 4 and we're splitting it up into groups of 3/5, the fraction. So I'm dividing 4 divided by 3/5. That's of course identical to 4/1 divided by 3/5. And I'll keep change flip. That first fraction stays the same. The division symbol becomes multiplication. And I find the reciprocal of 3/5, meaning I flip it upside down, for 20/3 weeks. Make sure that those final answers are circled with labels. Let's look at Tuesday next. On Tuesday night's homework, we're reviewing the process of completing a ratio table. I'm going to model question 3 because that's the most difficult ratio table here, and you can use the strategy in question 3 to solve any of the ratio tables given. Question 3 says, a shop sells bagels for $5 per dozen. We can see that in the table because 12 bagels cost $5. Complete the table to show the price of 1 bagel and the price of 2 bagels and the price of 30 bagels. That means my table needs 1 bagel, 2 bagels, and 30 bagels so that I can show those prices. I know that I need a magic number in my table to be able to find the price of a different variety of bagels. In this case, I'm going to find the magic number moving from right to left because I want to multiply price times something to find dollars. If I know that 5 times something equals 12, I can take 12 divided by 5 to calculate that magic number. Notice that 12 is the number of bagels, and 5 is the price. So I'll be finding the number of bagels that I can get for $1. I'm going to take 12 divided by 5, and I end up with an answer of 2.4, which will become my magic number in the table moving from right to left. I can multiply price times 2.4 to find the number of bagels. I get 2.4 bagels per dollar. So that's how much $1 gets me. The reason I decided to do bagels per price instead of price per bagel is just because if I had done it the other way around, like this, 12 times something equals 5, 5 divided by 12 gives me a really messy number, 0.416666. It's okay if you want to take this and round it to 0.42 and use that as your magic number here. But I'm going to stick with 2.4 just because it's a little bit neater. And remember that if I can multiply by something, in this case 2.4, moving from price to bagels, moving from bagels back to price, I can divide by that same magic number. And again, if you chose to do 0.24 or 42 rather instead, that's totally fine. We just have to be a little bit more careful about the rounding if we choose to do it that way. I'm pretty much finished now. All I need to do is start dividing. 1 divided by 2.4, which gives me 0.42. That makes sense because when I divided the price by the number of bagels over here, I did get 42 cents per bagel. And so it makes sense that one bagel would cost 42 cents. And again, that's why instead of doing times 2.4, I could have done, or rather, instead of doing divided by 2.4, I could have done times 0.42. And either way, I would get 84 cents for 2 bagels. And I'm just realizing this should be 30 bagels because that's what it asked me in the question. I'll leave that last row of the table up to you. The other question I want to touch on briefly is question 4. It says, the double number line shows the relationship between purple and blue paint. How much blue paint do you need for 20 milliliters of purple? So in this double number line, we can see that we have blue paint up top, 3, 6, 9, and purple paint on bottom, 8, 16, 24. They're asking us a question about 20 milliliters of purple, which would live right here, exactly halfway between 16 and 20. And I know it's exactly halfway because 16 plus 4 is 20, and 20 plus 4 is 24. That means that to find the correct amount of blue paint, I need to find out exactly what's halfway between 6 and 9. There are 3 spaces between 6 and 9, so I would just be dividing 3 by 2 to figure out what I'm adding, what my jump is. And that's one way to find the missing number. The other way to find the missing number is a little bit messier with what's given to us here, but we can find the magic number. 3 times something equals 8. And of course, I can just divide 8 by 3, which you could leave as a decimal, 8/3, or you could you could leave as a fraction, 8/3, or you could round the decimal, 2.66 is the magic number. So either way, whether you use the magic number or whether you see how you're splitting up your number line, you should end up with the same answer, but know that both of those are viable strategies. Let's look at Wednesday. On Wednesday night's homework, we're comparing unit price and unit rate. The key for Wednesday is that when we're comparing something like the bottles of juice in question 1, in order to compare, we need to find the unit price or the price per one thing. Or in a question like 2, the unit rate, the rate per 1 mile. So let's use question 2 as an example. A train and a bus travel at constant speeds. The tables below show the relationship between miles traveled in a given number of hours. Which mode of transportation travels more miles per hour? I'm simply going to calculate the miles per hour for both the train and the bus. Miles per hour. And I know I can find the miles per hour by dividing a number of miles I know by a number of hours I know. So the train is traveling 25 miles per hour. And those steps where I divide miles by hours, splitting up 100 miles equally between 4 hours, you want to do the same thing for the bus so that you can compare the train and the bus's miles per hour. So that's your final step on Wednesday night's homework. I'll leave that to you. Let's look at Thursday. On Thursday night's homework, we have a review of converting between fractions, decimals, and percents. I'm going to do one in each example so that you have something to work with on your own. When I move from fractions to decimals, I'm simply dividing the numerator by the denominator, so 1 divided by 4, which gives me a decimal of 0.25. And to move from a decimal to a percent, I'm simply multiplying my decimal times 100 for a percent of 25%. When I start with a decimal first, I can move to a percent by multiplying times 100, so 6%. And remember that this percentage symbol literally means per 100. So 6% means 6 per 100, or 6 hundredths. Of course, this fraction could be simplified because I could divide the top and the bottom by 2 for a simplified fraction of 3 over 50. And lastly, we have 6%. When I'm moving from percents to decimals, instead of multiplying by 100, I want to divide. And I get the decimal actually the same as the row above of 0.6. So I know my fraction is just 3 over 50 because Ms. Kinez included this example twice. 6%, 0.6, these are all identical. Remember that when you're moving from percents to decimals, you're dividing by 100 instead of multiplying because you're moving in the reverse order. That's Thursday night's homework. The other questions are just basic percent questions where you'll want to make sure to remember your setup, which is part over whole equals percent over 100. But with how well we did on our last quiz, I know you guys are experts on these. So if you have any other questions about the homework for this week, please be sure to check in with Ms. Kinez before the end of the day on Friday.